Okay, in this problem we're asked to find the trigonometric Fourier series for the voltage waveform shown below. So let's look at our waveform, and we see it here in the diagram. For instance, if we look, V of t exhibits even function symmetry. Okay, so V of t exhibits even function symmetry. F of t is f of minus t. So what does that mean, for instance, for our trigonometric Fourier series? That means b sub n is equal to 0 for all n. Okay, so we don't have to worry about calculating the b sub n's. We only got to calculate the a sub n's. So if we start off and look, for instance, our function has t0 equal to 6. Okay, so omega 0, 2 pi over t0, that's 2 pi over 6, or pi over 3 radians per second. So we know that the b sub n's are all 0. And now we need to calculate the a sub n. So let's start off with a0. So a0, 1 over t0, the integral from t1 to t1 plus t0, v of t dt. So then if we look at our function, we've got 1 over 6. Okay, now it has a value from minus 2 to minus 1 of 4. A value from minus 1 to 1 of 2. And a value from 1 to 2 of 4. So basically we have 1/6, we have 4 times 1, plus 2 times 2, plus 4 times 1, and that gets us 12 over 6, or 2. So there's a0. Now if we take advantage of the symmetry, then what we can do is we can calculate a sub n by taking 4 over t0, the integral from 0 to t0 over 2 f of t cosine n omega naught t dt. Okay, because of the symmetry, we really only have to go in there and integrate over half a period. So if we start, we have 4 over 6, and then if we look at our function, we can see from 0 to 1 it has a value of 2, from 1 to 2 it has a value of 4, and after that it has a value of 0. So we start off and say, okay, the integral from 0 to 1 of 2 cosine n pi over 3 t dt plus the integral from 1 to 2 of 4 cosine n pi over 3 t dt plus the integral from 2 to 4 of 0. So let's go through and begin the integration so we can reduce our 4/6 to 2/3. And if we integrate this, we get 2 over n pi over 3 sine n pi over 3t, evaluated from 0 to 1. And for the second term, we get 4 divided by n pi over 3 times the sine of n pi over 3t, evaluated from 1 to 2. Okay, continuing on, we get 2/3. Here we have 6 over n pi. We have sine n pi over 3 minus the sine of 0 plus 12 over n pi times the sine of 2n pi over 3 minus the sine of n pi over 3. And then obviously sine of 0 is 0. Okay, so now we need to continue on with our work. So now we can rewrite this as a sub n is 4 over n pi sine n pi over 3. And that basically comes multiplying this term by 2/3. And then we have 8 over n pi sine 2 pi n over 3. And then we have minus 8 over n pi sine n pi over 3. And if we look now, we can combine these two terms. So then a sub n becomes 8 over n pi sine 2 pi n over 3 minus 4 over n pi sine n pi over 3. So then v of t becomes 2 plus the sum from n is equal 1 to infinity of 4 over n pi times we have 2 times the sine of 2 pi n over 3 minus the sine of n pi over 3 cosine n pi over 3 t.